Finding the vertex from standard form. Standard form of a quadratic is f of x equals ax squared plus bx plus c. The a, the b, and the c will be replaced with numbers. The variable x is what's going to be used as a placeholder. So let's look at a problem with that example. So our problem that we're going to be working is going to be x squared plus 4x plus 3. It's written up here. When you're working the problems today, it helps to identify what your a, b, and c are. That's the numbers that are in front of your a is in front of your x squared. And since there's no number written there, that is understood to be a 1. Your b is in front of your x. And so it's plus 4, so we consider that a positive 4. If it was minus 4, we put that as a negative 4. And your c is a term that has no variable attached to it. And so in this case, our c is plus 3, so I consider that a positive 3. Now, when we were dealing with the vertex form that we've been working with for the last while, the vertex was easy to identify because it had already been separated out. Not all problems are going to have that done for you. So some of them you're actually going to have to calculate your vertex. And so to find your your x value of vertex, you're going to use this equation, x equals negative b over 2a. So in our story, or in our problem, our b is 4, so negative 4 divided by 2 times my a, which is 1. So negative 4 divided by 2, which is negative 2. That is going to be our input in order for us to find our y. And our y is when we plug that negative 2 into our function and come up with the output. And so our equation is our input squared plus 4 times our input plus 3. And so in this case, our input is negative 2. So negative 2 squared is the same thing as 4. 4 times negative 2 is a negative 8. So plus a negative 8 is 4 minus 8, which is negative 4. Negative 4 plus 3 is going to give us negative 1. So our output is negative 1. So that means our vertex is going to be located at negative 2, negative 1. And I'm going to go ahead and go over here and I'm going to plot that vertex on my graph. So negative 2, negative 1 is right here. So now, just like we were working with the last couple of days with the transformations, we're going to use those steps, and those steps, remember, were from the parent function, that to go to the next step up, we had to go up 1, and then we went up 3, and then we went up 5. Well, when there is a number in front of our x, then those will change. In this case, the a is 1, so there's no change to it. And so I just plug in those numbers. And so 1 times 1 is 1. And you would not have to show this work on if it was a 1. Oops. 3 times 1 is 3. And 5 times 1 is 5. And so I'm going to plot those changes. So that's going to be, this time it's a positive parabola because our a is positive. This number in front is positive. And so that means that I'm going to have this graph open up. And so my next value is going to go up 1 over 1. And so that's my next point. Then to get to my next one, I am going to go up 3 over 1, up 3 over 1. And that gets me to my next point. Then to get to the following one, I am going to go up 5 over 1, up 5 over 1. And so this is just giving me my points that I want to graph with, to graph that parabola. Tonight on the homework, I am not going to make you graph it, but you are going to have to identify these change points. And so you're going to have to identify the steps that you'll be taking. And these are the steps. So for the next problem, we have f of x is equal to negative 2x squared plus 8x minus 12. We need to identify the a, b, and c from this problem, just like we did the last problem. So the a is what's being multiplied times my x squared. So in this case, negative 2. The b is what's being multiplied to my x term. So in this case, 8. And the c is a constant at the end, negative 12. So when we plug this in, that means we have negative b, which is negative 8, over 2 times my a, which in this case was negative 2. So negative 8 divided by negative 4 gives us a positive 2. This is our x value for our vertex. So we're going to plug that into the function and find our output. So we have a negative 2 times our input squared plus 8 times our input minus 12. So this time our input's 2. So 2 squared is 4. Negative 2 times 4 is negative 8. 8 times 2 is 16, so plus 16 minus 12. So negative 8 plus 16 is 8. 8 minus 12 is a negative 4. That's our output. So let's go ahead and at this point we're going to go over and graph that vertex, which is at 2, negative 12, or negative 4, excuse me. Positive 2, negative 4 is that vertex. Now we're going to see how we're going to leave that point. So now let's look at our steps, and these are how we're going to leave that vertex. This time our a is negative, and that means that we are going to be falling as we're leaving. And so let's look and let's plug it into the steps, and it'll show you how when we plug it into that 1a, so that's 1 times our a, which is negative 2, we can actually see that it's going down from that. You can choose not to put the sign in here and just remember the direction you're going to be leaving. Or you can put the sign in and that kind of helps you find the direction. And so I'm going to use the sign in here to help find the direction. And so that gives us our changes as negative 2, negative 6, and negative 10, where I plug that in. With this window I chose for my graph, I'm not going to be able to see all of those graphed. We can plot a few of the changes as we go through them. And so the first point said that I am going to have a change of negative 2. So that means that I am going to go out 1, down 2, out 1, down 2. And the next one says I have a change of 6. Well, that's actually going to graph off my graph, and so I'm going to go ahead and just sketch. I know it's going to be down here. I know it's just barely off my graph paper. And so I'm going to go ahead and sketch where I think it's approximately going to be. I think it's going to be, when I go over 1 down 6, I'm approximating it to be about right here. Over 1. Oops, I went over 2 on that other side. Over 1 down 6. Over 1 down 6. And so now I'm going to go ahead and draw in my parabola, going from the vertex to each of those change spots. And that's an approximation of what the parabola would look like.